All right, our next parent function is a quadratic function. So with a quadratic, we have y equals x squared. So again, we can pick any x value that we want and plug it in. So I'm going to use my favorite 5. And this time, whenever we put an x in, we square it. So when you square something, you times it by itself. So if I had negative 2 squared, I'd be doing negative 2 times negative 2, which is a positive 4. Negative 1 squared is 1. 0 squared, 1 squared, and 2 squared. Notice that when you square a number, it always comes out to be positive. All right, so when we plot these points, connect them the best I could there. What you end up getting is a U-shaped graph. So this is a U shape, and this graph is called a parabola. All right, so the 0, again, is the x-intercept. It's here at 0, 0. The y-intercept, where it crosses the y-axis, is again at 0, 0. So notice that these graphs are centered around the origin. All right, this one has a minimum point just like the absolute value function did. So the minimum point is the lowest point on the graph, which is this point right here at 0, 0. Domain is what x values this graph hits. So x values run left and right. So notice I have an arrow on the left and I have an arrow on the right. So this graph is going to the left and to the right, which makes it all real numbers. All right, again, you can use your negative infinity to infinity if you prefer the interval symbols or interval notation. All right, range, remember, is up and down. So up is positive infinity, down is negative infinity. And we look for arrows that go up and down. Well, notice that my arrows, both of them point up, nothing points down. That means this minimum point right here is the lowest point on the graph and everything else is above it. So if you were going to do interval notation, you would put 0 with a bracket because 0 is an actual point to infinity. All right, if you want set notation, you can do all values of y such that y is greater than or equal to 0. So the graph is at 0 and above. All right, some other key features that you'll see on a quadratic is your increasing and decreasing intervals. So remember with these two, when it says decreasing and increasing, you trace it left to right. So if I trace this, and I start on the left and I trace it, this side is pointing down, so this side would be decreasing. Then it hits this point here, which is 0 on the x-axis. And then as I keep tracing, this side goes up. So we have decreasing, remember we use the x values. So decreasing is between the x values of negative infinity and 0. And again, 0 gets a parenthesis because that is not increasing or decreasing, that's its turning point. And then increasing, that I, is between these two x values, 0 to infinity. All right, positive interval. Positive is where are your y values? Positive. So that's above the x-axis. So everything above the x-axis would be positive. I did not want to do that. Erase. All right, so this whole entire graph, except for the point right here at 0, is above the x-axis. So remember 0, everything on here has a y value of 0, which is not positive nor negative. All right, so I'm going to do this in two pieces. So I'm going to do the left piece first. I can get my pen to work here. All right, so this piece here is between negative infinity and 0 with a parenthesis. All right, since we're not including 0, put a parenthesis, and then union, this yellow piece is between 0 to infinity. So that's your quadratic. All right, our next one is our square root function. All right, so we are picking perfect squares. All right, so the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. All right, so when I graph these, I have 0, 0, 1, 1, 4, 2, and then 9, 3 would be out here. So notice that there's only one arrow, that it only continues to the right. So this is the very first point on the graph. All right, so that's going to be important. So the shape, whatever you want to call it, I'll just say it's a curve. All right, 0, x-intercept is at the point 0, 0 still. Y-intercept, where it crosses the y-axis, is still at 0, 0. All right, minimum point, the lowest point on the graph. So that's the starting point right here at 0, 0. All right, domain, what x values does it hit? So notice, even though negative infinity is over here, I'm not hitting any x values until this very first point at 0. Then I'm hitting everything to the right, towards infinity. So I'm going from 0 to infinity. So you can write that in interval notation. Make sure 0 gets a bracket because it is an actual point on the graph. Or you can do set notation, all x values such that x is greater than or equal to 0. All right, range, y values. So remember, y's run up and down. And I have an arrow pointing upward, but I do not have an arrow pointing downward. So that means this minimum point at 0 is the starting y value, and then everything on the graph is above it. All right, so we can go 0 to infinity. Or if you like set notation, all values of y such that y is greater than or equal to 0. All right, and then we have increasing interval. Notice there's no decreasing interval because when I trace this, as I start tracing it, notice that I'm only going up. All right, so that's increasing the whole entire time. All right, so we're starting at 0. Remember, use the x values, going to infinity. So from 0 to infinity, and then again, 0 is the starting point. So at that point, it's not increasing or decreasing yet. All right, so it gets a parenthesis. All right, then positive interval. Notice there's no negative because the whole entire graph is above the x-axis. So the whole entire thing here, if I was to color in above the x-axis, this whole entire graph is above it. All right, so I want to say everything except this point because remember the x-axis is neither. So from 0 to infinity again would be all positive. All right. right, cubic. So we have f of x equals x cubed. So I can actually plug in any x value that I want, and you can cube it. So I'm going to pick my -2 all the way to 2. So when I cube it, I times this by itself 3 times. So -2 cubed would be a -8. -1 times -1 times -1 is -1, 0, 1, and 8. All right, so if I graph these, all right, so I like to say it kind of makes an S shape, like you can see how it kind of curves each direction, so I'll say S shape. All right, the x-intercept, the 0, is at the center still, 0, 0, the origin. The y-intercept still at the origin. All right, increasing interval. So remember we're tracing left to right, so if I trace this, and I start down here on the left side, notice the whole entire time I'm going up. That's why I don't have decrease written here. It's only increasing the whole entire time. And recall that we again use the x values. So I want to look at the x-axis, and it's increasing from -infinity all the way to infinity, the whole entire thing. All right, domain. So again, you have arrows on the left and arrows on the right, so that means it hits again all the x values, so all real numbers. Or you can do -infinity to infinity. All right, range, remember, is up and down, so we look for arrows pointing up and arrows pointing down, which I have on both ends, one pointing up, one pointing down. So that means it's hitting all the y values. So all real numbers are -infinity to infinity. All right, positive versus negative. So remember, positive is where your y values are above the x-axis. So positive would be everything above. And then negative would be everything below. So notice again that it changes right here at the center, the origin, 0, 0. So 0 is an important point, all right, it's where it's changing from positive to negative. So when I do positive, the yellow is over here. So it's on this side, from 0 to infinity. Then the negative, which is below, is right here on this side, which is in between the -infinity and 0.